First question, we're just trying to find the derivative. Here we've got to use product rule. So first derivative would be 1 sine plus x, now derivative of sine, which is cosine, so then x, sine of x plus x cosine. Your answer is B. Next one, I want to know where f is increasing. F is increasing where f prime is positive, so that means you need to find f prime. F prime would be 300 minus 3x squared. I like to have this negative 3x squared plus 300. That way I can factor out a negative 3, which gives me x squared minus 100, which means this is x minus 10, x plus 10. I want to know where f prime is equal to 0, so it's equal to 0 at 10 and negative 10. I'm going to make my little number line of f prime, negative 10 and 10. If I were to plug in 0, then this would be positive, and it's negative on either side. It's flipping signs. If this was squared, it wouldn't flip signs over that factor. So it's increasing where it's positive, negative 10 to 10. B. Antiderivative of secant tangent. I know secant tangent is the derivative for secant, so the antiderivative is just secant x plus c. And then double check, take the derivative of secant, yeah, it's secant tangent, so that checks out. Here to find f prime of 1, first find f prime of x, that would be 7, that goes away. Natural log is 1 over x, so f prime of 1 is 7 plus 1 over 1, which is 8. E. Which the following is false, the limit as x approaches 2 exists. That is true, it's not continuous, but the limit exists. X approaches 3, that one is true. It is continuous, that's a check. It is not differentiable. Right, you can't take the derivative here because the derivative is like not a smooth curve. It's called a cusp or a sharp term. X approaching 4, the limit exists. No, the left side is not equal to the right side, so that's false. 5, yes, that one is limit exists. It is continuous and it is differentiable, and the function is continuous at 3. Yeah, it is there. It's not differentiable, but it's continuous. Here I have the velocity. I want the total distance traveled, so distance would just be the derivative of the absolute value of the velocity from 0 to 3. So this is 6t minus t squared dt from 0 to 3. Antiderivative of 6 is 3t squared minus 1/3 t cubed evaluated at 0 and 3. So then that becomes 3 times 3 squared minus 1/3 of 3 cubed, and then the other one's like minus 0, right? So that's going to go away. So this just becomes 9. 9 times 3 is 27. 27 minus 9 is 18. So D. Just finding a derivative. So y prime, this is chain rule. So first bring the 5 down, leave the inside alone. Now it's to the 4th. Now multiply by the inside, that would be 3x squared. Derivative of cosine is negative cosine, so this will become is negative sign. So this will become a plus sign, so it changes signs. And then that one is E. Next one, it says the tank contains 50 liters of oil at t equals 4. It's being poured in. This is the rate at which it's being poured in. I want to find, I'm using a right Riemann sum to find the number of liters in the tank at t equals 15. So if I just go from 4 to 15 r of t dt, that just gives me how many liters are entering the tank or put into the tank, so go into. So that's the start, right? I'm going to do my right Riemann sum, which means use the right with the x values, or with the change in x. So this would be 6.2 times 3 plus 5.9 times this width is 5 plus 5.6, that width is 3. And then this one is 18.6, 29.5, 16.8, add them all together, you get 64.9. That's where people pick out A. But careful, all I found was the integral, right, from 4 to 15. That's only how many liters was put into from t equals 4 to 15. I know the tank had 50 liters at the start, so if I have 50 and I add how many I put in, that tells me how much I have at the end. So you have to actually add the 50 to it, which is where the answer D comes in. Oh, not D, sorry, C. This plus 50 is 114.9, so C. Here, if I want it continuous, I want on either side of 2 the function to be the same. So here you notice x minus 2 crosses off. I want to find what f of 2 would have been if it was like not this. So that would be 2 times 2 plus 1, which is 5. So you would need k to be 5 in order for these to match. It's like having a hole at x equals 2. And you know on either side it's going towards 5. It's just a hole because of the x minus 2 on top and bottom. If you want to fill it in to make it continuous, you need to fill it in with the y value of 5. U substitution, so it's saying u is square root of x, which is x to the 1/2. So du would be 1/2 x to the negative 1/2 dx. If I rearrange to get dx by itself, I would multiply the 2 up. This is actually dividing by root x, so I would multiply that up, and that would be positive. And now I can rewrite. So this is e to the u over square root of x. Dx we just said was root x to du. That cancels out. I'm going to pull the 2 out front, e to the u du. And I need to make sure I change my boundaries because it was 1 to 4, but now I need to find what u of 1 is. It's square root of x, so that's 1. U of 4, square root of x is 2. So now it is from 1 to 2 instead of 1 to 4. So then your answer is C. Next one, we're trying to find the integral. So integral, remember integral is just area. So I drew a picture, I think that's the easiest way. I want to go from 1 to 5. 1, 5. I know anything less than 3, that the value is just literally 2. So that makes this really easy, right? This is 2 and height of 2, so that's a area of 4. And then the next one is just a line, x minus 1. And it's going from 3 to 5, x minus 1, at 3 that would be 2, right here. And then the 5 would be at 4. So then this is just trapezoid. You can either do like triangle and this, rectangle or trapezoid, 1/2, 2 and 4, and then times the base of 2. So that becomes, this area is just 6. So if this area is 4 and this area is 6, from 1 to 5 the area is 10. This one, so I want to find the derivative of this. So that would be f prime of g of x times g prime of x. And now I want to find it at x equals 3. So f prime of g of 3 times g prime of 3. So first let's plug in, g of 3. So g of 3 is 3 times 3 minus 2. 9 minus 2 is 7. So this is f prime of 7. G prime is just going to be 3, so this is times 3. So I want f prime of 7 times 3. I need to find f prime. So f prime, this is to the 1/2 power, so it becomes 1/2 x squared minus 4 to the negative 1/2 times the inside 2x. That crosses off, so this is just, f prime is just x over root x squared minus 4. So then f prime of 7 is 7 over 49 minus 4. That's square root of, oh wow, really writing over this. That's okay. So this is 7 over root 45 times 3. Now you notice that's not an option, so I need to simplify. root 45 has a perfect square in it. 45 is 5 times 9. So if you have 9 inside of square root, that can come out, and that's the same as 3 root 5. So this is just 7 times 3 over 3 root 5. 3's cancel out, it's 7 root 5a. Here, so h is defined as the integral. H prime would then just be f of x. H double prime would be f prime of x. And we're looking at 6. So h prime of 6 is just f of 6. F of 6 is 0. F prime at 6, that is a positive slope. And then this was the h of 6 would be the integral from 0 to 6. From 0 to 6, that is a negative area. So I know that h of 6 is negative, h prime is 0, h double prime is positive. So then it's like already kind of in order, in increasing order, because this is negative, 0, and positive, like that. Particle moves, its position is this. I want to find where it's at rest. Where it's at rest is velocity equals 0. So before I find the derivative, right, I'm going to actually multiply this out. So box method, t minus a, t minus b, that's t squared minus at minus bt plus AB. So x is t squared minus at minus bt plus ab. If you take the derivative to get your velocity, that would be 2t minus a minus b. This is just like constants, right? It says a and b are constants, so that one would go away when you take the derivative. You want your velocity equal to 0, because I want to know where it's at rest. So solving for time, this would be 2t equals a plus b when you move both of these over. Divide by 2, and that's your answer, B. Here, f of x is defined as this integral. I want to find what g would be. So think about f prime of x. If you take the derivative of this, you just get g of x. So I want to know what the graph of g would be. So really that's just a graph of f prime. This is a graph of f. You notice that f has a constant slope, which means that f prime is constant. If f prime is constant, g is constant. So the graph should be constant a. This h approaching 0, you've got the function plus h without the h and divided by h. So this is just means derivative. This is the derivative of natural log of x, and it's evaluated at x equals 4. So it's like the same as if I said, okay, f is natural log of x, what's f prime of 4? So f prime would be 1 over x, and then f prime of 4 would be 1 over 4, which is b. I want to know which points would the line tangent have the slope. So basically, where do you have f prime equal to 1/2? So let's find f prime. You would do quotient rule. Low d high minus high d low. Underneath the low squared goes. So you've got x plus 2 minus x, that just becomes 2. We want to know when this is equal to 1/2, so set this equal to 1/2. Now we cross multiply. You've got 4 equals x plus 2 squared. Take the square root. That could be plus or minus 2 equals x plus 2. So when you subtract over, you've either got 2 minus 2 or you've got negative 2 minus 2. This would be 0. This one would be negative 4. So x could be 0 or it could be negative 4. So then that's C. Here you're taking derivative of an inverse. So this is a super niche rule. It doesn't show up very often, but we did learn it last semester when we were doing derivatives. So the inverse, if you take derivative of the inverse, that's the same as 1 over the derivative of the inverse value, like this. Well, I think I put extra parentheses, but that's okay. So first things first, I would find the inverse, because remember g is just the inverse of f, so if I'm asking for g prime, that is asking for the inverse of f prime at 1. So let's find what the inverse of 1 would be. So plug in 1 here, equals 2 plus 1 cubed. Cube root of 1 is 1. Subtract 1 over, so x equals 0. So now I know this is just going to be f prime of 0. Now you find f prime, which is 3, 2x plus 1 squared times derivative on the inside. And then f prime of 1 is, this is 6. Oh, sorry, f prime of 0. So then this is just 1 squared, so this is just 6, so this is 1 over 6, D. I want to know which one has a horizontal asymptote, y equals 5. So this is horizontal asymptote is Bobo, Bodhi, eats DC. Whatever, DC. Big on bottom would be 0, not what I'm looking for. I'm not looking for infinity. I want to divide coefficients. Sine of x, 5x over x does not give me 5. That would not be a horizontal asymptote. This one would be a 0. This one would be 5 over negative 1, so that would actually be y equals negative 5, not the case. Here I'd have the 20 over the 4, which is positive 5, so E is your answer. We've got G. I want to know which one does G have a critical point at. So critical point is where the derivative equals 0. So first find our derivative. So G prime would be 2x e to the kx plus x squared e to the kx, and you multiply the k down when you take the derivative of this one. If I set this equal to 0, I'm going to factor out an x and an e to the kx. I'd be left with a 2 plus an x and a k. That's equal to 0. I know, so obviously x equals 0, and this one, nothing can make this term 0, so I'm focused on this term right here because I'm looking for k. I want x to be 2/3, so 2 plus 2/3 of what value of k, so this is equal to 0. Subtract over, multiply the 3 and the 2 like this, that becomes -3. So your answer is A. If we know this is your slope, so you can think about it as like y prime, to get y, you would take the antiderivative, right? Antiderivative of 2 sine would be -2 cosine of x plus c. And negative because when you antiderivative sine should be negative cosine, right? And then now we need to find what c is, so we're going to plug in x is pi, and that's going to equal to a y value of 1. Cosine of pi is -1, 2 times -2 times -1 is 2. Subtract over, that means c is 1, so you've got -2 cosine x plus -1 or -1, so that's e. Here, g prime is your integral, so then that means that g double prime is the e to the -x squared dx. So I started with the concavity. I don't know, I just like to not have the integral. So if my concavity, right here from 0 to 2, right, even though I have a negative exponent, that just makes it a small number, it doesn't make it negative, so g double prime is going to be positive, which means that it is concave up. So concave up, I'm going to cross off B and D. There wouldn't be a point of inflection because at no point, no x value is going to make this negative, so it's just concave up, it's not changing concavity. So now I'm between A and C. So I need to decide, is this right here positive or negative? This is just area, right? So I'm going to sketch e to the negative t squared will look something like this. It's getting smaller, but again, the value of the function is not actually negative. So then your area would be positive. So because g prime, the area in this case, is positive, that means that g must be increasing. So your answer is A. Here, so I got dy dx by itself. So dy dx equals 2x minus y over the x plus 2y. And I want to find the second derivative, so I'm going to take the derivative of this again. So, product rule. So low d high would be 2 minus dy dx, minus high d low would be 1 plus 2y, underneath the low squared goes. So I'm going to start plugging in the x is 3 and y is 0. So that goes away, that goes away, that goes away. And x is 3, so this is 3 times 2 minus dy dx, minus 2 times 3 is 6 times 1 plus 2 dy dx over 9, because 3 squared. Now I need to know what dy dx is, but I can just plug in. So again, y is 0, so 2x is 2 times 3 over 3, so this is just 2. So I can plug in a 2 here and a 2 here. 2 minus 2 is 0, so this term goes away. 2 times 2 is 4, plus 1 is 5, so you've got -6 times 3 over 9, this is -30 over 9, that's -10 over 3, which is A. Last one, so we have position. I want to find acceleration where velocity is first equal to 0, so first find the velocity. Derivative would be cosine, and then that one become plus sine. And then I'm also going to be asking about acceleration, so let's go ahead and find it. That would be negative sine plus cosine. I want to know what the acceleration is where the velocity is first equal to 0. So let's say velocity equals 0. That would be cosine t plus sine t equals 0, which means sine is equal to negative cosine. Think about your cosine and sine values are equal at the pi over 4s, right? When it's like the basically 45 degrees, the halfway in between, but they're only opposite signs here and here. This one is the first one, so that would be the 3 pi over 4. And then that's the t, right? That's the time you're looking at, and then you need to know what is the acceleration at that time, so you just substitute it in. So negative sine of 3 pi over 4 plus cosine of 3 pi over 4. And then this one is, the cosine is the negative root 2 over 2, and then the sine is positive, but it has a negative out front, so root 2 over 2. And then that just becomes equals negative root 2, A. A lot of trig there. Alright, now we're allowed to use a calculator if we want to. The graph of the function here, I want to know which of the following is, this is f. Where is f prime positive and increasing? So think about f prime positive means that f is increasing, and f prime increasing means that f is concave up. So I want to know concave up and increasing, so it should look something like this that I just circled or darkened. So then E is the only one that is concave up and increasing. Intermediate value theorem. So this one, if you have f of 2 is 10, 2 and 10, and f of 4 is 20, and the function is continuous, that means that somewhere between 2 and 4, you have to pass through every value between 10 and 20. So x equals 13, or f of x equals 13, so that's somewhere in here. I am guaranteed to at least have one value between 2 and 4 where the function value is 13. Yes. You are guaranteed that 3 is 15. No. I'm guaranteed a 15 somewhere between 2 and 3, or 2 and 4, but I don't know which x value it is. There has to be a maximum. No, not. F prime, no, we're not talking about the f prime. Intermediate value is literally the values, not like the slopes or derivatives. So A is the only one. Here we've got a graph of f prime. We're seeing which of the following is true. So relative minimum at x equals -3, that's going f prime negative to positive. So yes, that's a minimum, check. Point of inflection at x equals -2, right here. No, because f prime is increasing and it's still increasing. So f double prime doesn't change signs, so not this one. And it is concave down from 0 to 4. F prime is decreasing, so then f double prime is negative, that's concave down. So 1 and 3 are both true. Water is pumped into a tank at this rate. If the tank contained 800 gallons when the pump was turned on, how much does the tank have after 20 minutes? So you have 800 gallons, you're gaining and pumping in at this rate. So you're going to take the integral from 0 to 20 of this dt. And we have a calculator, don't try and do that one by hand. So we're going to go to our calculator. Integral is math 9, I'm going from 0 to 20. This is 30, 1 minus e to the negative 0.16 x dx. This right here is the 420.1429, and I still have to add it to the 800, so then plus 800 gives me 1220 gallons d. This one, I want to find the estimate of the distance traveled from 0 till it comes to a complete stop, which is at 8. So 0 to 8, the absolute value of the velocity. I don't really have to worry about absolute value because it's all positive. So here, we're just estimating this area. So I would say this looks something like a triangle, right? If I were to just draw a triangle right here, then it would be base of 8 times height of 50 divided by 2. Now I get 200 for that area, so I'm between these two. Now we have to think, was this an over or an underestimate? So see how this one I underestimated right here, but then I overdid it a little bit right here. I actually underestimated more than I overestimated. Hopefully that's making sense. I underestimated more than I overestimated. So then if I got the 200, then that is an underestimate, so it should be the 210. Let me double check with my key. No, it should be the 180. Okay. Did I do that right? 8 times 50 over 2. This one is a little bit over. Maybe I didn't draw that in a straight line. I'm gonna have to come back to that. You can ask about that in the morning. I mean, definitely between these two, right? That's so weird. I got 180 earlier. Okay. We'll move on. So second derivative is given right here. I want to know concave down. Concave down is f double prime is negative. This is literally a graph of f double prime, so it's negative here. X less than -1 in between 1 to 3. So less than -1 in between 1 and 3, so that's E. Here we are looking if the particle's velocity at t equals 0 is 5. What is the velocity of the particle at t equals 3? We have the acceleration. So think about, we know velocity of 0 is 5. We want velocity at 3, and we have the acceleration. So I'm going to set up an integral. The integral from 0 to 3 of the acceleration would be the antiderivative acceleration, which is velocity of 3 minus velocity of 0. Velocity of 3 is what we're looking for. Velocity of 0 is 5. And then this, we can just go to our calculator. We can take the antiderivative of that function. So math 9, we're going from 0 to 3. It's x plus 3 divided by square root of x cubed plus 1 dx. So then this integral is 6.71. Add the 5 over. That becomes 11.71 is your velocity at 3. So E. Here we know that the area from 4 to 7, the area is 0. You only have area 0 if it's like flat or if you have like some positive, some negative. It says that f prime is positive for all real numbers, which means f is increasing. So that means I started negative and I went positive. That way you have some negative and some positive, so you can have a net area of 0. So I first checked which of these have f actually increasing. This one has f increasing, that's good. This one has it increasing, that's good. This one has it increasing then decreasing, no. Doesn't change at all, no. This one is increasing, that's good. And then now I just need to check which of the ones starts negative and goes positive. Negative, but then it's only negative. So I wouldn't have an area of 0, it would be a negative area, so not A. This one is negative and goes positive, that's good. This one starts at 0 and only is positive, so I'd only have a negative area, not 0, so then B is the only one. 8, we've got a person, this height right here is 6. The height of the street lamp is 15, and they're moving away at a rate of 4 feet per second. So I'm going to call this distance like my x, so dx dt is 4. What is the rate at which the shadow is lengthening? So I set it up like triangles. You have proportional triangles. So 15 over this entire distance, what do I call it, x? Yeah. Equals 6 over, I call this right here x. X plus the shadow. Whereas this is like the shadow, is 6 over just the shadow. Cross multiply, so you've got 15s, x equals 6s equals 6 times x plus s, 6x plus 6s. Subtract over, that's 9x, divide by 9 over. That is 2/3 x for s. And then I want to know the rate which the shadow is changing, which is ds dt. Is 2/3 of dx dt. We just said that dx dt is 4, so then this is just 8/3, which is 2.667. 90, you had one on your test this week, very close to this, so you've got f of 2x. I want to make it look like f of just like 1, so I'm going to use u is 2x, that means du is 2dx. So then I'm going to rewrite this as f of u. Dx is du over 2. And then my bounds, if I'm using u, right, this would become u of 6, which is 12, and u of 12, which is 24. So I've got 1/2 of f of u du, oops, still an integral, equals, and it still equals to 10, because I haven't actually changed the value, from 12 to 24. So then if I multiply this up, I get the integral from 12 to 24, f of u du equals 20. So that is what, which one says B? Last multiple choice, which of the following must be true? We've been given f prime. So keyword here is must be true. Concave up would be f double prime is positive, which means f prime is increasing. Actually, I see that it decreases, so f prime starts decreasing 3 to 1, then it increases, and then it 7 to 5, it decreases again. So that cannot be true. The graph of f has at least 2 points of inflection. Points of inflection is when f double prime changes signs or f prime changes from increasing to decreasing. Oh look, you have a point here and you have a point here, at least 2 points. F is increasing, yes, f prime is positive, but you don't know that there's not a negative in between, right? I could have think about the graph of sine, right? If you always looked at these ones, you would think sine is increasing the entire time, but that's just because you have several points where it's increasing. You might be missing the points where it's decreasing. So that could be true, but it doesn't have to be true. No critical points, we know that they're, again, there could be critical points. Right, I don't have any f equals zeros or negatives, but there could be, f prime, sorry. So don't know, and at least 2 relatives, we don't know that. B, you know for sure though. Alright, derivative. So before you find m prime of 1, you have to write out your m prime of x. If this was like a 2 or 3 point problem, you would get one of the 2 or 2 of the 3 just from your m prime of x. So low d high minus high d low, underneath the low squared goes. Now we can do m prime of 1. It's 3 times 1, which is 3. F prime of 1 minus f of 1 times 3. 3 times 1 is 3 squared, so this is over 9. F prime of 1 is 4. 3 times 4 is 12, minus f of 1 is negative 2. Negative 2 times 3 is negative 6. Minus a negative is plus 6. So that's 18 over 9, which is m prime of 1 equals 2. Find the slope of the tangent line to the graph at g at x equals 2. So you need g of 2, and you also need g prime of 2. So g prime of x, I'll start with that, would be 2x plus e to the 2x minus 4 times derivative of the inside, which is a 2. So then g prime of 2 is 2 times 2 plus 2, e to the 2 times 2 is 4 minus 4. 4 minus 4 is 0, e to the 0 is 1, so this is just a 2 right here. 4 times 2 is 6. So g prime of 2 is 6. G of 2, we're just straight plugging in. 2 squared plus e to the 4 minus 4. E to the 0 is 1, so this is 4 plus 1, which is 5. So that's my function value, so y minus 5 equals, slope is 6 times x minus 2. Find t prime of 1, but first find t prime of x. That would be g prime of 2x. Do not forget to multiply by 2. We're using a product rule here, but within the product rule you have chain, because g prime, or derivative of g of 2x is g prime of 2x times 2.